Good afternoon, colleagues. I am Regina Maphanga. I will be chairing this BOF session on modeling and on South African roadmap for modeling and simulation. So I would like to officially welcome everybody to this session. The session is titled South African Modeling and Simulation Roadmap, and those who attended the opening session yesterday will recall from the presentation that was given by Dr. Jeffrey Valoy that we will have this session, and I guess we are here. He indicated that there have been ongoing discussions between our organization, the CSIR, and the Department of Science and Innovation, particularly on the DSI decadal plan, focusing on ICT foundational digital capabilities, where modeling and simulation is one of the domains that were identified. So these ICT foundational digital capabilities are mainly those capabilities that are related to 4IR technologies. And some of you might have seen from the program that we've got a very short program that we are going to run with it as fast as possible so that we finish everything within an hour. And we have only 5 items, which we'll try to do our best going through them. And as such, I don't want to waste much time, but move straight into the program, which I will now, from this short welcome, I will now call Dr. Jeffrey Valoy to give us the presentation on the second item called Background and Objectives for Modeling and Simulation Program. Okay. Thank you. I'll hand over to you, Dr. Jeffrey.
No, thank you, Prof. Maphanga, and good afternoon, everyone. As it has already been said, I did share a short introduction to this topic that we're discussing today, the modeling and simulation roadmap. As I said yesterday, I'm calling it a roadmap simply because we are not the primary drivers of the decadal plan. So this is driven by DSI, Department of Science and Innovation, on behalf of the whole of our government. So they are coordinating it in conjunction with the other departments within government to really build this decadal plan for the benefit of the whole country. So this 10-year program is to really build our capabilities in terms of technologies for the country, so that we are really ready and to really take advantage of the opportunities that will be there, and even the challenges themselves that we are always present, that we're dealing with. And as all of us, we are aware now, we are all dealing with one, as we speak now, the pandemic. And everybody will agree that this pandemic will definitely, and we have used it actually, although one can argue that there were some shortcomings in terms of the modeling and simulation capabilities that we have brought to bear to really assist our government in responding and coordinating our response to this. But be that as it may, we have really used it, but I'm sure everybody can agree that we can really do more in case something like this happens in the future. So without wasting much time, I will share my presentation that really gives a background, and for the benefit of those that were not there in yesterday's session, I'll just repeat some of the slides, the main drivers for why we're working on this, the roadmap, which really will feed into the decadal plan. So we can see why we're doing this, and then after me, Prof. Maphanga will sort of present our response, what we're proposing to DSI, which will form part of the decadal plan once it gets approved and finalized for implementation from the beginning of next financial year. So basically the beginning of March next year, 2022. So you'll bear with me, colleagues. Just show it here. I hope everybody can see my slides. Okay, I'll assume you can see them. So as I said, we are working on this modeling and simulation roadmap, which will feed into the decadal plan. As I said yesterday, this modeling and simulation, what's called the foundational digital domain, is one of 6 that the DSI has actually put onto the proposed decadal plan to really develop these foundational capabilities, not applications, but foundational capabilities that any application targeted at particular sectors of the economy will sit upon. So you can develop applications targeted at health, which will need some or if not all of these foundational capabilities to really have effective applications for that particular sector. Or if we look at mining, or you look at energy, the environment, the natural environment or built environment, you can imagine that any of these foundational capabilities can be brought to bear to really build effective applications that can be developed for that. So the focus of DSI is to really develop these foundational capabilities, not necessarily applications. Even for ourselves, initially, we were struggling to understand about how can you develop capabilities without necessarily going all the way to applications. But they don't want to go there without partnering with a sector departments, so if you will. So that's they are thinking in this area. So now the focus of this talk, the focus of this session that we're having now, is on the modeling and simulation foundational digital domain. And the same thing is happening with the other foundational domains that I'm showing there on the screen. A similar thing, our colleagues at the CSR and outside the CSR are working on them to develop these proposals, put them into the plan so that they can start being effective, going from being effective, starting from next financial year. So today we'll just, and in this session, we just focus on the modeling and simulation foundational digital domain. So yesterday, what I shared was that DSI, they saw this from really 3 focus areas. The first one being conceptual modeling. And I'm sure, I know I'm probably preaching to the converted here, because this is your space, guys, in the modeling and simulation space, when we talk about conceptual modeling. But then we want to look at these questions not only within 1 or 2 subdomains of modeling and simulation, but we go beyond, where when you start combining different models from different subdomains, how can you make them talk to each other and you still trust the results coming out from those simulations, from those models? So the first question is, when you look at conceptual modeling, say, how can models expressed by different experts, as I said, I'm speaking to the converted here, in different modeling languages, be combined in a consistent fashion? So basically, you're combining them to really want to solve something that's more like a grand problem, like, for example, the pandemic we're facing now. As you have seen, that it affects economic health. Basically, the physical space that we occupy, are told that you must be confined in your homes. You can't go there. You can't go to this. You must reduce the numbers. All of that, can it be modeled? Can you combine different models from different angles and still have something that can really inform decision making? And you can imagine that if this was in place, most of the decisions that were made would have been different from what has been taken by our government, by our leaders, both for us as a country and for the rest of the world. So what level of formality is suitable for efficient and effective communication? So I won't read all of them, but you can see them, that what it talks to. So you need to be able to get to a point where you can really come from any subdomain of modeling simulation. And if you see a problem that needs multiple domains to really tackle it, you can come together and bring it, put together the submodels to make one bigger super model, if you will, that you can really solve that particular problem. And there I give an example of using system dynamics. That's what it does, basically, in a way where it brings different subdomain experts, subdomain models to really solve one big problem. But it can go beyond that. So then another focus area, like I said, I won't go through all these questions. They're all on the screen there. Another focus area was the fidelity of models that we build and the uncertainty of those models, especially now when it comes to the issue of yes, you can quantify the uncertainty of a particular model, but then when you combine it with a model from a different area, a different subdomain, now how do you measure that uncertainty? So you have to establish maybe a new way, a new framework, a new protocol of really quantifying that uncertainty. So yeah, some of the question could be, what is the most appropriate approach to represent and reason about uncertainty in complex systems? And you want to do it consistent, not just once, but something that you trust, and it's a tried and tested method to go about quantifying that uncertainty and also reasoning about it. What is the approach to characterizing the uncertainty associated with a simulation model in order to enable and facilitate reuse? So as we all know that sometimes the models that gets produced and developed are not necessarily used by the developer, are used by other people out there. So you need to be able to develop something that can be reused further and further for the benefit of the whole community, if you will. Just not to be exhaustive in looking at all these questions, I can pick one of them. Say, what are the most promising approaches to accelerate the validation of models for specific application context? Specific, yes, but you can also look at specific in the sense that you can have a unique situation where you didn't think about it before, but then now the problem that you are facing, you need to solve is so unique that you realize that, as I said, you need to bring in different experts from different angles to really attack that question. But now, how can you accelerate given the time pressures that we have? I'm sure most of you are aware that when this pandemic was discovered, then we had to act very quickly. We had to put systems in place, develop systems in place very quickly, such that we can really advise our governments, both in South Africa and the rest of the world, for them to make these decisions. So you can imagine the pressures that you have before you can really validate the model the way you used to have time maybe to validate the model. You need so many months or weeks, whatever. But now you don't have the luxury of those weeks. So all of that can really be something that we need to tackle, such that we can really have a mechanism in place that can really accelerate that validation if you need to put it in place. And then the other question I can just highlight is what are the key challenges in multi-resolution modeling and the most promising approaches to address them in a targeted application domain. So all these that's the things that DSI really wanted that whatever gets developed in the next decade, we really can talk to this, and we can really tackle any problem that our country can face. And we can really be in a position to really advise decision makers wherever they are sitting, be it the private sector or even in government. And then the third focus area is the reuse, composition, and adaptation of models. So the first question could be, how can a model user be confident that the planned reuse of the model is within the range of uses intended by the model creator? Within one domain, this is easy. This has been, we know we have done it many times. There's not an issue. But then when you start to combine it with different other areas, subdomains, then it's a different question that we still need to answer. In some cases, that has been attempted, maybe if you combine one or two subdomains, but then if you go beyond that, that's one thing that we need to, like I said, in the first focus area, consistency is the most important quality that we need to have in whatever we're developing in this. One question that I can also highlight is can one characterize the uncertainty of simulation models obtained through composition of multiple models? So some of these look like they are repeating questions, but they're also important that we need to make sure that we really capture all of this in whatever we're developing. So as I said, what we're proposing, as Regina will be showing after I'm done with my presentation, we'll talk to this and see how we propose to tackle this. And as I said, we are hoping to get really good suggestion from you guys from this, and we can really improve what we're proposing for DSI to have in their digital plan and then can be implemented. And as you know, 10 years is a long time. Obviously, things can change in that period. So the objectives broadly that we've put together for this program, and Regina will just break it down in terms of how we plan to meet these objectives that we've come up with, is that we want to develop these interdisciplinary frameworks that demonstrate collaborative modeling and simulation R&D in science and engineering disciplines. So in the short and long term, that's what, for the whole period, basically, that's what we want to develop this framework, so that it's easy to combine and have models from different disciplines or subdomains of modeling and simulation to really talk to each other. There's a framework that's been put in place, there's protocols that have been put in place. And I guess in a way, we can even develop to the point of standards where we say, this is how you go about combining different models from different domains, subdomains. And it's established and accepted by the whole community. And it makes it easy for anybody in this space and anybody from outside who wants to use those models to really be able to trust the results that are coming from those models. The second objective was to design educational programs that leverage technologies relevant to industries to facilitate learning while imparting knowledge for the next generation. So yeah, it talks about because when you look at the capability, broadly you can look at them at three levels. You can look at the skills level, where you look at the HCD, the people that the capability reside in, people, the knowledge that they have. Then you can look at the infrastructure. Here we're talking about specifically the CHPC, where we see they're going to be core in this for the community, for South Africa essentially, because we don't see this at the level where somebody's just running it at their own computer. Want to run it at the level where you can bring to bear the capability of CHPC and the cloud infrastructure that they're building now. So we need to have that capability both, as I said, at the human capital level, then at the infrastructure level, and the processes level. So processes, that's when I talk about the standards, protocols, the frameworks that are in place, where this is how you go about doing this. So we were talking about, you need to be deliberate in really developing that capability in the human capital, that they know how to go about implementing this, how to develop it, and taking it forward, because you know something that you do it and it's static. It's ongoing, as we all know. And then we want to build a community of practice for modeling and simulation experts from industry, academia, and also in government. And then want to develop interoperable frameworks for variable models at various length and time scales. So as this talks to the frameworks I was talking about, the frameworks, the standards, and the protocols. And then we need to coordinate and develop integrated data management tools, frameworks, and repository. So here we should make sure that this is well, if you will, for the look of better word, the curatorship. All this knowledge, all these tools and systems are well curated, and this we can, as time goes on, we can talk to different partners, but we can obviously see where an entity like Nikis can really play a very important role in this space to make sure that this is well preserved for the benefit of the country. And then also to interface, as I said, high performance computational resources with architectures that will be developed, software architectures that will be purpose built to make these resources, make these tools that we're talking about, the capabilities to run at that using that high performance computational infrastructure that's sitting with the CHPC, with Nikis. Because like I said, what we are foreseeing here, we're not just looking at one individual researcher being able to run on the, obviously that can be done and it will be developed at that level, but then we need to develop such that it can run on the CHPC infrastructure or anything similar to that for the benefit of the country. So colleagues, that's my introduction to this modeling and simulation roadmap. I think I will hand over to Regina now. I guess questions can be asked after Regina has given a breakdown of how we plan to tackle and really reach these objectives I just shared now. No, thank you, colleagues. Regina.
Yes, Jeffrey, thank you so much for the presentation. We will have a question and answer, and as well as the discussions at the end of the two presentations, meaning that we'll now move to the second presentation, which I will do. And as indicated, I will focus mainly on presenting the proposed business plan. So the reason that we are presenting these ideas or the business plan to the CHPC annual meeting participants is that the reason is that it is known that the modeling and simulation community operates at CHPC. In fact, they reside at CHPC. So if one is to access modeling and simulation community, CHPC is the first place to go to. Hence our presentation or our engagement here today. So what I'm going to do in the next few slides, I will try to look mainly on the proposed ideas that these are the initial ideas that we looked at, and I must mention from the beginning that these are not prescriptive, but the initial thoughts and ideas that we came up with as we were discussing with the DSI. And from the desktop studies that we conducted, we found that there are 10 key work domains that are used to categorize technical and hurdles encountered in modeling and simulation, research development, and innovation. And these challenges are cross-cutting. They are in most cases linked to each other. And I have a list of them here, which I'll try to summarize some of the proposed ideas that we have. Firstly, we have a program on development of models and simulation methods. Then closely related to that, we've got the optimization of existing methods. Then we proposed a program on decision making and uncertainty quantification. The next one on multi-scale, multi-phenomena modeling, where we develop models and methods. Then there's also ideas around verification and validation, collaboration frameworks and workflows, and most importantly, education and training, because without the workforce, all these other programs cannot function. So education and training plays a very important role, I think, compared to the other programs. So hence it appears here. Then we also have some ideas on high performance computational infrastructure and scalability. Then lastly, we have programs that are related mainly to data-driven modeling and simulation, where the first one is about the data informatics and visualization. I believe we're all aware that since the beginning of science, there's been gathering or generation of data that is sitting somewhere else. Some of that data, it has never been explored or it has never been utilized fully. So that's an emerging area that modeling and simulation as a domain can play a huge role. Related to that is the development of data-driven models and simulation methods. So what I'll show in the next few slides is to go through a few of these programs. I will not go through all the details, but just to give an idea of what are the things that could be done. And you'll see from the presentation that some of the proposed ideas, the answer to the questions that were presented by Jeffrey under different focus areas. Then the first one is about the development of models and simulation methods. What happened is that the different types of models can be developed for different applications. And I guess that's what the community has been doing over the years. And it is a common knowledge that this area is, it has been fully exploited, and there are successful stories out of this. However, when we come to complex systems or integrated systems, it is sometimes not possible to develop such models because of their complexity. And also when we are working on larger scales, it might be difficult to optimize some of the existing simulation methods. So that's hence we identify this as one of the programs that could be explored. And there are two gaps that are really identified under this program. We realize that there is an underdevelopment of physics-based models for complex systems, and also there is a lack of reliable optimization methods that bridge across the scales. So what we had to do was to identify the gap and propose some strategic interventions and propose the timeframes for each and every program. So I will not go into a deeper detail of the activity levels, but what is important is that out of each and every program, there must be a deliverable. And in this case, examples of those deliverables could be integrated models or multi-scale models and methods frameworks, and also enhanced optimization algorithms. Then closely related to the program that I've just talked about, this is more on the multi-scale, combining the two or more scales together and see how can we develop a complex system based on that, or not necessarily complex system. How do we develop systems that could solve some of the societal challenges that we have in the country? So the gap that we identified is that there's an underdevelopment of physics-based models that are capable of linking different length and time scales, and the proposed activities or strategic interventions are listed there with their time frames. Then we've got some examples on the deliverables. We can have integrated models, multi-scale models, and methods frameworks. So this is also an emerging area where it has been realized that yes, we can accurately use the methods at their respective scales, but it is generally difficult to link or couple the different scales. So the program will mainly focus on that. Then we've got model validation and verification. So this was asked in one of the questions that, or several questions that were presented. So what we identify here is that there's generally lack of guidelines and practitioner aids for multi-scale or multi-physics validation and verification. And those are the strategic interventions that could be considered, and also the deliverables. We can have some calibration or validated estimate and uncertainty in optimization routines. Then I talked about the importance of education and training. So this is one of the programs that was identified, and I know that in most institutions at the moment, there are no special programs that are focused on modeling and simulations. In most cases, the students will be trained under the general science or engineering streams. It's only when they go to higher levels that they will choose to specialize in modeling and simulation. So as you can see, some of the strategic interventions, it could be to have a standardized modeling and simulation modules. We can have some short courses on modeling and simulation. That I know that the Hpc has been doing some work in training, particularly for students. It might not be necessarily on modeling and simulation, but I'm aware that they are running several programs on training students. And also we can have some strategic interventions on workforce transition training for students, training on specific issues like verification and validation frameworks. And also I do acknowledge that there is a a good participation of students to either to access or use Hpc facilities, but given the importance that 4IR technologies will play in the future, we might need to look, we may need to look at increasing those numbers to a higher number, such that as a country we are able to adapt or adopt the 4IR technologies. And the next program is on data informatics and visualization. This is mainly about using the data that has been generated since the beginning of science. So it could be a well-structured data or some metadata. So there's a lot of there are a lot of activities that could be looked at under this particular program. And the gap that we identified was that there are no widely accepted community standards or schema for materials or processes, information storage and communication methods. So that's something that could be developed as one of the programs, and the types of deliverables that could come out of the program. It could be a case where as a country we have a common data repository. We can also have standardized database and multidimensional visualization tools. I know that in several of developed countries, they already grabbed this opportunity on using the data that is available to make innovations. So there are a lot of databases that were developed in the past 5 or 7 years or so, and that's the place where we go today when we need models and some information related to some models. So that could be explored as a program. Then also we have the HPC infrastructure and scalability. So this will include your computer hardware, firmware, software, networks, platforms, and HPC. So I think this is the area that even if it's identified as a program, we might not take a control. This belongs to the CHPC, and I know that a lot has been done in this regard over the years. However, the reason that this was mentioned was that as we intend to have a collaborative or community of practice on modeling and simulations, we may find that there are some groups that have codes that are not able to run on HPC architectures. So as part of the program, it could be explored on how do we take the codes, particularly those that were developed in South Africa, how do we modernize those existing code? Then what are the best practices for the multi-domain workflows? Then can we create some web platform for code benchmarking? So these are some of the initial ideas that we had on HPC infrastructure. And as I said, this belongs to CHPC. I think what the program could do will be to leverage what they've been excelling on and see how does the modeling and simulation domain benefit from that. And the next one, which is also very important, is more on the collaboration. And collaboration comes in two formats. It could be a physical collaboration where human or organizations collaborate, and it could also be a technological collaboration where we share resources such as codes, models, methods to contribute to the program. Then again, we have to identify the deliverables. Then the one that is key, I think, is to build or establish a community of practice for modeling and simulation. I know that there is a community that already exists. We've been having some user group meetings during CHPC annual meetings, but that can be expanded to include other people who are not part of the CHPC, particularly those colleagues that are operating in industries, because the main aim is to take the models that we develop in the laboratories to the industry. And the last one is on decision making and uncertainty quantification. So I'll not go through this, but it's one of the key. Some questions were asked about uncertainty quantification, as we have seen from the questions that were asked. So the program was also proposed. Then in conclusion, I think looking at the different programs that we have identified, and I must stress that the programs are not prescriptive, and also we have not decided on which of the programs will be run. So the idea was to put everything together based on the technical hurdles and challenges in modeling and simulation R&D. And as I mentioned, that the main aim on the development of models and simulation methods, including the optimization of methods, is to take the models and the methods that we have kept in the laboratories to see how do we implement those models to solve industrial problems, with the ultimate goal of commercializing such models. And in terms of multi-scale modeling tools and methods, we intend to use modeling and simulation, or we intend to raise awareness that the modeling and simulation can be used to solve real problems. And in terms of verification and validation, we can develop tools and systems that will assist in validating the different different models that are available. Then in terms of collaboration, the ultimate goal could be to establish a community of practice on modeling and simulation, to collaborate both physically and technologically. And in terms of education and training, it is expected that the universities will play a leading role, particularly on developing modules and courses to train modeling and simulation workforce. And in terms of high performance computational infrastructure and scalability, we could leverage on Hpc capabilities. And as I said, they will be the major role player, both in terms of technical and physical collaboration. They are already providing resources for everyone in the country. And also they have meetings like the one that we are having today, where we can collaborate physically. Then in terms of data informatics and visualization, then we have to see how do we extract value from existing data, particularly on the data, on unique data that we generate in South Africa. Because if we could go to the global, at a global scale, we may find that some of the data has already been, or value from some of the existing data has already been extracted. So we may need to focus particularly on the South African situation. Then lastly, on the development of data-driven models and simulation methods. So the aim for this is to really to accelerate the decision making, and also provide advanced decision support. So in this case, what the program proposes is that using the data that is available, how do we develop models using AI or machine learning techniques? Because when using those, one can quickly make decisions compared to when one has to use the conventional methods on simulation, on modeling and simulation. And the last thing that I want to talk about is the South African Modeling and Simulation Roadmap. So given the program and the activities that could be done, we propose that maybe in a short term, there could be a roadmap that will guide the research direction for modeling and simulation in the country. Several other countries, particularly in Europe and the US, they have already developed their modeling and simulation roadmaps, and I think some are even over 6-7 years old. So they've been running the programs for quite some time now. And that will be all from my presentation. And thank you very much. And as we indicated that we will have a discussion and questions at the end of the session. So I will now go back to the chairperson role, where I will try to look at the questions that were asked. So Jeffrey, you will help answering the questions. So there's a question here which says, how does this initiate, how does this initiative link with NIFEX? This is an institution that has formed by DSI to support theoretical and computational sciences. Do you foresee any common points? So that's the question.
Just to answer that, this initiative will link with all institutions, as you have alluded there, even other science councils beyond the CSR, so your Mintex, your ARC. So what we are proposing here was being looked at by DSI. It's these are sector agnostic capabilities, so it can be applied to any sector. So in order for us to develop these tools and these frameworks and standards and the protocols that I've mentioned, we'll have to touch base with each and every single one of these institutions to make sure that whatever they are doing in their domain can really be fused and work together with another domain. And those ones that are working in all domains, they'll sort of definitely play an important role in actually making sure that what they've already developed for themselves can actually be used. And there's this term called cross-pollination that can really be used to really infuse and maybe even increase the development of other subdomains that may be far behind others that are way ahead. So definitely part of the need of this program is engaging with other stakeholders. This is one of the first engagements that we are putting together, but we will definitely engage different institutions individually. The universities, I know some universities are leaders in terms of particular subdomains of modeling. Just to mention a few, the University of Limpopo, they are leaders in materials modeling, we know that. University of Cape Town, they are leaders when it comes to chemical engineering, the modeling in that element, that side. So different institutions, universities, and research councils, even the private sector. Some companies are quite big, quite huge, and they lead in this space. We'll have to engage them to see how they can bring their expertise, to really work together to really, because this is beyond just government. It's for the whole country, for the benefit of for ourselves economically, and also for social development. So we'll definitely engage the different stakeholders, maybe not necessarily all at the same time, but as Regina had said, we'll start some of these programs. We won't start all of them all at once. We'll start some of them earlier, the others will come a bit later, but we'll definitely make sure that within the 10 years, everything is developed, is in place. I hope it answers that question.
Yes, thank you, Jeffrey. We've got a hand from Queen. You may come in.
Hi, can you guys hear me?
Yes, yes.
Okay, thanks, Jeffrey and Regina. I can see you guys have done a lot of hard work on this, and it's nice to see somebody taking a bit of initiative to try and put in a bit of a roadmap and a structure around it, so well done on that. I've just got a few comments and thoughts, not really specific questions, I guess. Just first of all, I think I agree 100% on the human capital development angle. That's probably one of our biggest limitations in South Africa. I think, you know, these sort of technology-oriented skill sets are very, very hard to come by. It's something that's a challenge that's felt by industry very, very critically. So I would agree that we need some sort of initiatives to really push the development of modeling and simulation as career paths in South Africa. 100% agreed on the verification and validation issues. I think that, some sort of central large database that everybody can contribute to from a wide range of different fields and disciplines in terms of both providing verification and validation test cases and also testing their own codes and things like that against it would be extremely useful. And also agreed 100% on the data repository issues. I think what we really need to be pushing for here is, particularly maybe more on the academic side, is for open data, but not only open data, but open science. So, just in terms of ensuring repeatability and verifiability, all of these kind of issues, we don't do anywhere near as much stuff with open platform tools as we should. So then just a couple of sort of concerns maybe that I have. I think, Jeffrey, you did mention it now in your answer. It's really important that you guys engage with the other science councils and research centers of excellence and the universities and things like that. You really don't want to risk this coming out almost fully formed out of DSR and CSR as a CSR project, because then it's going to be very difficult for you to get buy-in from everybody else. So start sooner rather than later with that would be just my recommendations. Then the other thing is, don't put the cart before the horse with industry. I would be approaching them early on right now. Remember, modeling and simulation is currently heavily applied in industries across the world, and there are massive industries in South Africa that can benefit directly from this kind of stuff. A lot of them are doing that work themselves already in-house, maybe not the best sort of way, without a lot of guidance. Make sure that you go and talk to them, get them involved in this decision-making process, because it's no good doing a lot of really nice academic research and then sort of sitting back and saying to industry, hey, come to us and we've got all the answers now. I think you need to be working with them right up front to identify the kind of where are their pain points, where are their challenges, what's fair, what are the issues facing them? Because a lot of what you've listed here is certainly very relevant to the academic environment, but I think we need to make sure that it's relevant to the industry users as well. So engage those guys as well as early as possible. And then, I think maybe just one example of that would be something like, for example, in coupled multi-physics modeling, really simple stuff like materials properties and parameters that you put into these models are actually massive sources of uncertainty in many industries out there in the real world. And you might find that, some of the aspects like that are where we can really add a lot of value. So the industry engagement can help guide and shape this as long as you involve them early on from the beginning. And then they also have a bit of an investment in it in terms of, we were engaged with this early and we'd like to participate, rather than just somebody showing up on their doorstep with a fully formed document that says, right, guys, please follow this. But yeah, good. Keep up the good work. Thank you.
Okay, thank you so much, Queen. Jeffrey, would you like to make a comment related to what the Queen has just said before I go to the next question?
No, thank you for that for that comment, for also for the advice. We'll definitely do that. You are right there. From our side, we definitely have to hit the road running, engaging the different stakeholders, and definitely the one on industry. As we know, in South Africa, they're not as receptive as they should be into modeling and simulation. Maybe part of the reason is ourselves, we're not doing a good job really in selling this capability. Definitely can make a huge use of it. So definitely we'll take your advice on that one. No, thanks for that, Queen. Regina?
Yes, we've got another question here. It says, how do you propose to get investors to help with this roadmap? The reason I'm asking is that curriculum for higher education, especially in chemistry and physics, is usually set by old people. They don't want to change the curriculum. I tried, didn't work.
Okay, no. Maybe I guess a bit of incentive can assist in this space, because If you think about this, let's say the 10 years have lapsed, who do you think will be the people who will have to implement this and run this? It won't be this, as you say, the mature people, the old people. It will be the youngsters. Probably some of them are at university, at high school right now. Because if you think about it, in 10 years' time, those guys will be the ones with the PhDs and what have you. So we really can't stand back and just let the curriculum be what it is. We have to influence it, both as the industry, modeling and simulation industry. The same way as you know, at least maybe for the professional side, like the engineering, the industry itself, engineering the body, engineering discipline influences the curriculum. Maybe something similar, but not as maybe, because maybe for them they use the legislation to do that. But we need to bring some reason to say that we need to change this to adapt, to make sure that we're up to date as a country with the rest of the world, because otherwise we'll be left behind. There's no way we can claim to play in that space if we're not influencing the curriculum. We have to change the curriculum to really not reflect what is currently needed, but what we think will be needed in the future. Because most of us, we are aware of what we will need to do to be in a place where we can really tackle any problem that the country will face, both economically and socially. Because like I said, if we use the pandemic as an example, I'm sure most of us can see that real modeling and simulation could have can really help in making these decisions for our leaders, for our political leaders. So if it was there, it will make some of this, maybe reduce some of the damage that has been done economically and socially. Could have been much less. I hope I answered the question and there, but obviously we'll need all the support we can get.
Okay, we have Verna's hand. I'm trying to ask to unmute Verna. You may come in. Thank you.
Hi, Regina. Thank you very much, and thank you for you and Jeffrey for bringing this topic to the fore and explaining what the thinking is that's been going into this. I think it's very good, because I want to agree with Quinn. I mean, this whole concept of modeling and simulation and taking that forward as one, let's call it concise and commonly understood theme of things that needs to happen is a bit lacking. But I put up my hand before Quinn started to talk, and he touched on the things that I wanted to mention, and this is about industry. I want to just share a practical observation that we've seen at CHPC. Of course, CHPC is open for industry to come and use it as well, same as academic and public institutions. But we've never seen more than 1% of the hours that is being consumed at the CHPC to be used by industry. So initially we thought, well, if we just go out to industry and we talk to them and tell them how easy and how cheap and how beneficial it is for them to use HPC, they will come. But we soon realized that is also not working, because the problem is industry, or a lot of traditional industries, do not recognize the importance of modeling and simulation. They do not see it as something serious. They might have, if they have a research team, they might allow one person part of his time to play around with some modeling and simulation, but they don't recognize modeling and simulation as some serious science that should be incorporated into their complete research effort. So I'm just making this observation because it could link very nicely with the initiatives that you are talking about here, to bring this to the fore and to get industries involved early, especially those ones, when I say traditional, so the more experimentally focused industries where modeling and simulation is not that important, to get them to recognize. And then once they recognize that, I think the offering from the CHPC will become more understandable. So we realize it doesn't help to talk to industries about HPC. We first need to get the recognition of modeling and simulation over. So this is more a comment, but thank you very much for what you are sharing.
Okay, thank you so much, Verna. I didn't see your hand earlier. I'm sorry about that. But anyway, Jeffrey, do you have comments based on what Verna has said?
Yeah. No, thanks, Regina. I think what Verna said is actually supporting what I said, that industry really, in South Africa, in general, they don't really use the modeling and simulation capabilities. So as I said, maybe it's us, we really need to work hard to really sell these capabilities, show them the benefits they can gain from it, the savings, because industry, it's all about profits. So if something that can increase their profits, they can see it, then maybe we need to demonstrate it to them and say, look, this is what you can gain from this. But then this is beyond, because this we have been fighting with for many years. But this goes beyond that. We really also need to increase the capability to really grow it beyond just silo subdomains of modeling and simulation, where you have that capability to really combine it, because as the more we understand the world, the more complex we see how the world is, and the more you realize that I need to build really complex models here. A silo mentality doesn't work anymore. So the idea is that by the end of the 10 years, we can have that capability in place and can easily be demonstrated to anybody that needs to look at it and make use of it, be it industry or government. So I think that's the aim of this initiative. And maybe just to answer to what Krishna Gavanda said, maybe we need to put funding in place. So that's the whole idea of what DSI is doing. They're aiming to put, obviously, it won't be a lot of money, but some money towards that to assist in really developing this capability. So there will be some money that might go for that.
Sorry, Jeff, would you mind if I read the question so that viewers may know what you're answering to?
Oh, sorry.
You're not able to see.
Yeah, apologies for that.
So I'll read both Krishna's question and Queen's comment. You'll tackle them together because we are almost towards the end of the program. So Krishna asked, would it not be beneficial to start setting up funding that will take advantage of both modeling and experiment? The more the old way of working is funded, then things may not change. So that's from Krishna. Then Quinn said, this project may be a good vehicle for publishing case studies, short, concise documents that demonstrate how industries have benefited directly from modeling and simulations. Yeah, you can answer to Krishna's question.
Yeah, thanks for that. As I was saying to Krishna's question, so basically, I'm assuming when you say modeling and experiment, you're talking about the physical experiment part. So that's the whole point when Regina was talking about the data-driven modeling and simulation. That's the whole point where we take advantage of all that data that has been accumulated through the physical experiments that have been run, even the new ones that are coming. As it comes in, it can feed data. As you know, the idea is also take advantage of the new techniques like your machine learning, deep learning. We infuse it with your traditional modeling and simulation to really improve our models, to get better in that space. So definitely the idea, wherever there's data that can really infuse, can improve on the models and the simulation that we're running, we're going in that direction. That's the idea. And as I said, the funding, a little bit of funding is there from DSI, but obviously the idea is to also really use it to activate other funding from other sectors, other departments, other sectors of the economy, private sector, to really build this capability. And as Quinn said, they said the project may be a good vehicle for publishing case studies. Yeah, so yeah, the initiative, yes, it's good, but it will be very broad. We want to tackle everything and anything in this space where we can really improve and show the benefit of modeling and simulation. And as you are right, that for industry, like I said, we need to develop something that they can see that, yes, we can really benefit from this. Because I think maybe, as I say, maybe the blame is on us, not necessarily on them, because you can't really blame somebody for not using something if they don't see the benefit of it. So along as we're developing and running this program, this initiative, this domain, as we're growing it, we're hoping to really develop this showcase studies. So we can show them and say, look, this is what the benefit we can do. You can gain from it as an industry. So maybe something that's specifically targeted to them. That's the idea. and hopefully we can have that, and they can actually take it up. And as you know, once industry gets involved, things can really grow, can get big, and maybe some of the their funding they have that they will have to put aside for R&D, because as you know, as a country, if you combine funding used for R&D both by government and industry, I think it's less than 1%, which is not good enough. So maybe this can help activate that, especially from the industry side. So I hope I answered both questions satisfactorily.
Yes, thank you so much. I think this will bring us to the end of our session. If there are no other questions or comments, otherwise it's now 1 minute over the time that we were allocated. However, from my side, I will just maybe summarize what has been said. So this was one of the first engagement that we initiated, and we would like to thank everybody who made time to attend and share some ideas. And there were a few things that came out that came out strongly. The first being that we need to do more engagements, as you might have, Jeffrey. So we need to work really hard on that and see how do we engage even further, particularly on the industry side. So that has not been done. But otherwise, this is still at the very beginning, and we will try to expand on these engagements and try to include all the important stakeholders. And also the other thing that came out is about human capital development. We understand that is core, because if we want to fully take advantage of the opportunity or this modeling and simulation domain, we need to have manpower prepared as early as now. So those are key things that we would work on going forward. We will still come back to particularly CHPC. Verna will come back to you several times. I guess sometimes it could be maybe when we need to know what are the participants. I know you've got these slides that you normally share during the presentation during our user group meetings, where you show the participation from different institutions. So we may need to, if we need to understand who are the players, we may come to you. And also, obviously, there is a lot that the Hpc and this initiative have in common. So we will work closely with you, and we will engage all the other users that have been working closely with CHPC and see how do we move this forward.
You're most welcome, Regina. I think it is a no-brainer that CHPC should be part of this. Modeling and simulation is what we are promoting, what we are doing. So I'm very pleased about this initiative. So we are ready. We are more than ready. So whenever you need our inputs, we are there.
Okay. Without taking much more time, I would like to thank everybody for making time and attending the session. We'll keep you posted going forward. So as I said, it might be through CHPC for now until we get systems in place. Thank you so much.
Thank you, colleagues.
Thank you.
Thanks, everyone.
Thank you. Bye.
Bye.